the sky. We see them flying free. That's just like you and me. Everyone is lonely sometimes, but I would walk 1,000 miles to see your eyes. You are not alone with your family. Hold me, let's escape all this reality. You are my symphony. By your side, we are united. You are my energy, my guiding light. We are unity. We are although the rain might part, the thunder starts to roar. The lightning wave.
Mathematics, you all welcome. And then today's chapter will zero much on a topic: quadratic equations and inequalities, and particularly the quadratic equations. Quadratic equations. Otherwise, before we commence on any discussion, let's first pray. Jesus, we thank you. Father, we bless your name for this presentation. And then we ask you to guide us, lead us. As human beings, we actually can't do this unless we are under your guidance. For we can do everything with you who strengthens us. Strengthen us, Father, and give us the grace to discover more. All this we pray, believing through the mighty name of Jesus Christ, the Son who lives and reigns within the unity of all Spirit, one God forever and ever. Amen. To all the Muslims, we also welcome, and we believe that whatever we pray through the mighty name of Allah, we surely receive. May we receive the wisdom, the knowledge and understanding that is required to maneuver this journey of mathematics. Otherwise, thank you so much. Let's get into the new A-level principal mathematics. The new A-level principal mathematics. In the first presentation, we discussed the topics that we are to cover in the first term, and all of them, you'll find them in these presentations. Then shall also discuss the topics in the second term of Senior 5. Otherwise, to all mathematicians under the new O-level competency-based curriculum, this topic is very, very important, particularly the equation, quadratic equation. So all the information that we shall share here, you actually also need it. So if you get time, pause the video, learn something, basically on the methods of solving quadratic equations. However, the Senior 5, Senior 6, you go beyond that, so you have to complete the tutorial. So we agreed that we base on a competency, or each topic must have a competency, and the competency for this topic particularly is the learner investigates equations and inequalities to acquire mathematical, computational, and analytical skills applicable in the real world. The learner investigates equations and inequalities to acquire mathematical, computational, and analytical skills applicable in the real world. So for us to achieve this competency, we must have the learning outcomes. And then also to achieve those learning outcomes, you must have the learning activities. What a learner has to do in order to be in position to portray the outcomes or to portray the objectives achieved. So by the end of this tutorial, by the end of this topic, the learner should be able to, 1. Interpret the solutions of quadratic equations in various real-life contexts. Why are we saying the learner? Because we are assessing a learner per learner. We don't take you as a group. So we based on you individual achievement, individual competency. So you can't achieve a competence as a group. So we are going to base on one by one learner. And then particularly for this tutorial, I will zero much on the first learning outcome. I repeat it. Interpret the solutions of quadratic equations in various real-life contexts involving optimization. Meaning you need to know you need to have some knowledge, the understanding, you need to possess some skills, the values, the attitude, and the generic skills. And these are skills that are beyond mathematics we shall learn here. The skills that will enable you live in any other context, in any other community. So throughout this, we shall be in position to acquire all that. And then B, I think this will be the next presentation. We shall zero much on applying solutions of linear simultaneous equations in 3 variables to solve real-world problems involving multiple constraints. So in O-level, we got used to these simultaneous equations of the caliber of 2 unknown variables, maybe x and y, where you are given a scenario, and then you have to generate equations, the 2 simultaneous equations you solve for x and y, maybe by elimination, matrix method. And then in this level, we go to the context of 3 variables, where we have x, y, and z, or the variables b, a, b, c, where you have 3 unknown variables and you have to solve them and then make valid deduction or decision as far as the final response is concerned. And then part C, that will be the third presentation, how apply quadratic equations or inequalities, quadratic inequalities, I repeat, to determine the feasible region sets in real world scenarios. Still in O level, we had this linear, we had these inequalities, but it was more of forming the inequalities, the linear inequalities. Then you represent them on a graph using the knowledge of linear programming. Then you shade the wanted, unwanted region, and then you locate the feasible region. You create or you generate the coordinates, and then we use them to make either maximize or minimize. And then here we are going to solve quadratic inequalities, meaning having a quadratic equation, but instead of having equal sign, we get inequality. And then we get the factors. Solve those factors. They give you the values, the appropriate values of x in terms, if the inequality is in terms of x, I mean. And then we solve this. On solving, we instead get the region within which the solution lies. So we call it the feasible solution set. And then we shall continue to hijack the real life scenarios. So basically we shall have 4. The last one will be manipulate polynomial equations and expressions for solving problems in various contexts such as engineering, economics, and physics. So throughout the chapter, we get to realize that you need to have the knowledge, the skills, the understanding, the values, the attitude. You must have a positive attitude in to this presentation and to this topic in particular, equations and inequalities, vis-a-vis the generic skills. So what you learn from here should enable you live in another society. Live in a society where we are not actually talking about mathematics, but something else. So the GS should enable you do that. So today we have a discussion part A, and then the next presentation, please keep checking, I will upload all of them, and then equations and inequalities will be done. So let's zero on the first one, just like I said. Interpret the solutions of quadratic equations in various real-life contexts involving optimization. So the suggested learning outcomes, the suggested learning activities, I call them what a learner has to do. Since I'm assessing you as a person, as a learner, then you have to do something as far as the activities required for you to be in a position to interpret the solutions of quadratic equations and also apply it in the real life scenarios that involve optimization. Here we are meaning maximizing, if it is profits, we are maximizing profits, or minimizing costs, minimizing expenses. I mean minimizing losses. So throughout this, you must do something, and on doing that, or through the process of doing that, you acquire the skills, you acquire the knowledge, you acquire the attitude, the values, and the generic skills that will enable you maneuver this or pass through this presentation, pass through this chapter successfully. So some of them, and these are the things that I always advise you to sit down and make research using different sources. Now, since I've piled everything in this presentation, so this is what you need to base on and do the research. I will judge a class that has maybe 2 and above students. So at some point we shall have group discussions. So that's why I'm saying we shall go through a group discussion again in this context. So in groups, learners review different methods of solving quadratic equations using factorization, completing square, and then quadratic formula. So this is a review. We already have this in all levels. So sit down, make research, and come to those equations, and then know how to solve them by factorization, completing square, and the quadratic formula. Part B, still in our groups, we shall discuss how to express roots as sum and product using the coefficients of quadratic equation and formulate quadratic equations using the new roots. So you need to be in the position by the end of this topic, you need to be in position to also get any other root and form a quadratic equation. For example, if x is equal to 2 and x is equal to 3, when I make factors, open the bracket, multiply everything, way to 0, then I have a quadratic equation, but in terms of x. And then if I give you other roots, alpha and beta, and then being the roots of this quadratic equation quadratic equation in equation, you can also form them. And if I give you other roots, you should be in also position to form those equations. We should also share and also solve simultaneous equations that have the linear and nonlinear terms. Well, in the first presentation on logarithm and indices, logarithm, indices, and SADs, we agreed that throughout the journey of solving equations involving log and index of variables, at some point we end up reducing these equations to quadratic equations, and then we get stuck with solving them. And then I anticipate that through this discussion, after you've acquired the knowledge of solving quadratic equations using the factorization, completing square, and the quadratic formula, and also we have a graphical method by that, then you'll be in position now to complete your process, to complete the process of solving the function you had that appeared in log, form, or in indices form. We should be also in position to apply the method of completing square to 1. Determine the maximum and the minimum values, e.g. maximum profit, minimum profit, minimum loss, minimum costs. And then we shall represent the information graphically, meaning solving that thing graphically. And then verify the nature of roots of quadratic equations using the discriminant. So the discriminant is that part of the general formula or the quadratic formula that helps us to test for the nature or to verify the nature of the roots of quadratic equation. And this can either be two distinct real roots, repeated real root, or complex root. In other words, when we press this, to those who know how to use a calculator and solve it, when you press this, you find the math error in your final answer. As you're trying to get to the final answer of the quadratic equation at hand, on pressing the variables a, b, and c, the constants a, b, and c, you find that the calculator gives you a response of math error, meaning that quadratic equation has actually complex root. And then at some point, actually it gives a root but with a complex sign, real, imaginary. Sometimes you don't need to read that value. It gives you x is equal to 2, but it's a complex up. So it shows you a complex sign, and then that one is a complex root. So you have to confirm that. Or on the other hand, when you're using bulldozer or the quadratic formula, you get a situation where you take the square root of a negative. On simplifying b squared minus 4ac, you get a negative value, and then at that point you get stuck, because when you press square root of negative value, it gives you a math error. So that's why we shall call that no real root. Instead, it will be a complex root. And to those in advanced level, you get to understand what we talk about when we mean complex numbers. Otherwise, basically, that's what we shall have at the learning activities, or what a learner has to do. Then we shall still continue to quadratic equations. So a quadratic equation is in the form ax squared plus bx plus c is equal to 0. And then the methods of solving quadratic equation range from factorization, where you get the factors. Factorization comes from the word factor. So if you have factors of a quadratic equation, then you can use them to act as the answers in the subsequent manipulation. Completing the square or completing square method, general formula or formulae, or the quadratic formulae, and then lastly graphical method. So throughout this tutorial, we must be in position to know all those, apply them, understand them, apply them, and solve very many quadratic equations, whether you're given or you have to generate them from the scenario. The example we have, solve x squared minus x minus 2 is equal to 0. Now if you look at this and you compare it with the standard quadratic equation, ax squared plus bx plus c is equal to 0, we identify that the coefficient of x squared is 1, coefficient of x is -1, then the constant is negative t is equal to 0. So we have very many methods. I will start with factorization. Factorization, we base on the coefficients. Now if you critically check, you get to realize that the coefficient of x is a -1. So that -1 is the one we shall take as the sum. If it is a +20, that is the sum. Then the product is multiplication of the coefficient of x squared, what you have here, which is a 1, +1, then times the constant. The constant, you take it with its sign, so that's why I'm taking -2. So for that we shall get the product. Product instead will be, the product will be -2. So the factors will be 1 and -2. And then we think within the box or outside the box, if you can. Think about the two numbers that when we add, we get -1, and then when you multiply them, you get -2. Those very two numbers. So we can realize that the two numbers are 1 and -2. So those are the ones we call factors. So when you add 1 plus negative 2, you get negative 1. And then when you multiply them, you get negative 2. So we get back to our function. And then we replace this whole x. What we are targeting is a perfect factor. We are to replace this very variable here with its sign. So we are replacing it with 1x and negative 2x, because when I add them I get negative x. So that we are replacing the sum, replacing this very part here. And then for that case we shall have our new function as x squared plus x minus 2x minus 2 is equal to 0. Because when I reverse this, I get back to the original function. Pulling out the common factor on each stage, I have that, and you can see that x plus 1 is common on the two parts of this quadratic equation. So I just take x minus 2 and one of this equal to 0. So for this case, if you have a product of two values or variables and they are all equal to 0, it means that one of them is equal to 0, or the other is also equal, or all of them are equal to 0. So that's why I'm taking either x minus 2 is equal to 0, then x is 2, or x plus 1 is equal to 0, x is equal to negative 1. So we get to realize that therefore the values of x are 2 and 1. Completing square. So the rules are very simple. 1, the coefficient of x squared must be 1, meaning you divide it throughout by the coefficient of x squared. Now since in our question the coefficient are meaning the neighbor of x squared. So that neighbor must be 1. To make it a 1, you have to, this part here, you have to divide it through by that value. Divide everything by that, with its sign. Divide through such that you reduce it to 1. Because when you divide a number by itself, you get 1. So that's why you have to make it 1 as the rule is concerned. So that is the rule of completing square. Step number 2. So that's what I said. Make sure the coefficient of x is 1. Sorry, x squared. Coefficient of x squared. There's a mistake here. Should be x squared. Coefficient of x squared. And then we get a half of the coefficient of x, which is a half of negative 1. And then that will go to a half. Then you square both sides. You square that half. And then you add on both sides of this equation. As you can see, I'm adding the result. And then what I'm targeting is to get a perfect square. The perfect square is got from this part, where since this is squared and this is squared, I just add x plus a negative of this, plus the whole of this, negative of that. So that will give me a perfect square. Then I take it as a square. So on getting a perfect square, remember we must have the same response using all the methods. So that's the perfect square I'm talking about. The other side, I take the square root, add everything. Taking a square root on both sides, I get my value. Of course, the square root of a number is either positive or negative. So I take the positive one and also the negative. So by the end of the day, by the end of the week, we shall have the same answer, and that will be x is equal to 2 and x is equal to negative. X is equal to negative 2. So the answer should be the same. The answer should be the same. And this is negative 2, sorry. This is negative 1. So the answer is negative 1, negative 1, negative 1. Yes. So general formula, we just quote that formula. I think in A level, unless they change it, you already have the logbook and this equation is already there. So we just use it and identify A, B, C, D. So when you look at the quadratic equation at hand, we just need to compare it with the standard quadratic equation, which is ax squared plus bx plus c is equal to 0. Then we identify A, B, and C. So our A is A. Our A is 1, which is the coefficient of x squared. Our B is negative 1, which is the coefficient of x. And C is a constant, negative 2. Substituting back to the formula, respectively, since we have a plus or minus, we take a positive, get x is equal to 2. We take a negative, x is equal to negative 1. So finally, still our answer is 2 and negative 1. Our response is 2 and negative 1. So that is the third one. Let's move to the fourth method, graphical method. Graphical method. So the graphical method, what we shall do is very simple. You set a range. You set a range, and then the range of values of x. For me, I took negative 3 up to 4. You can also take yours. You can just estimate the values of x, please, within the number line. So you can take negative 4 up to negative 4, negative 5, negative. But you need to estimate a range within which you anticipate the value to lie. So for me, after realizing that my answers are negative 1 and 2, so I don't need to go very far. So that's my range for that. Then I carry that value of x, substitute in x, that very x, substitute in this, in the quadratic equation. Then I simplify the whole quadratic equation. On simplifying it, what I get is f of x. What I get is f of x, or it is the y value that I will plot. So I will plot a graph of y against x. So just take your time, press in the calc, and get those answers. I have my 10, 4, 0, negative 2, negative 2, 0, 4, 10. And this will act as coordinates now. These are coordinates I'm going to plot. So I will plot, remember we start with x, plot that. Plot negative 2 with 4, negative 1 with 0. I plot 0 with that negative 2, 1 and negative 2. I plot 2 and 0. I plot 3 and 4. I then lastly plot 4 and 10. How do you tell that your answer is already within the range? You tell the answer or the responses within the range. You read the value of x when y is equal to 0, because that is when we have the x-intercepts. So the two values of x when y is 0, in other words, when the curve cuts the y-axis, sorry, the x-axis, are this, the coordinates we have are here, meaning the values of x that will be, our response will be negative 1 and positive 2. So at that point we have x negative 2, y 2, and then the y values will be 0, and then here also 0. That's when we have the curve cutting the x-axis. So let's plot this and we see whether it is true. So I already have a plotted graph. Kindly allow me pass through it with you. So this graph is here. I have it is titled already, a graph showing the solutions of the quadratic equation x squared minus x minus 2 is equal to 0. Please always create a title depending on the scenario. Now I can see my axis, y-axis, x-axis. Don't forget to label the axis, Now on the plotting, we can see that I'm starting with negative 3. Negative 3, I plot it against, plot it with 10. So it is somewhere here. Then negative 2, 4, it is here. Negative 1, 0, it is there. And then 0, negative 2, I think it's there. I move to 1, negative 2, 1, negative 2, well plotted. 2, 0, plotted. 3, 4, plotted. And then lastly, I have my 4, 10. So the curve is already plotted here. Now let's try to interpret the solution or the response of the value x. So we can vividly see that at points where the curve, which curve is this? We have already labeled it as x squared minus x minus 2 is equal to 0. So at points, or at a point where this curve cuts the x-axis, that's when we read the possible solution. And the possible solution here we have is x is equal to -2 and x is equal to 2. So therefore the values of x are 2 and -2 from the graph. So you can see that using all the 4 methods, we still get the same response. Now allow me pause something here to those advanced learners. Kindly, if you want to get the maximum value, let me explain this from here, although we shall find it in the next lesson. If you want to get the maximum value and the minimum value, remember, a quadratic equation has only one value, whether it can either be maximum or minimum. And then for the U-shaped, for this case, it is a minimum. So you read the value, of y, where it is turning. So ultimately here, you can see it's moving to almost -2 point something. So the minimum value. And then for the maximum, it must be, maximum value must be n-shaped. Must be n-shaped of this caliber. Then if for example this is our y-axis, maybe it's a standard curve, then this is, so the value where that curve makes an n, or where it is sharply turning, making a n-shaped curve, that is when we read the value of y as the maximum value of the function. And then how do you tell that the function has a maximum or minimum value? You get to read the coefficient of x squared. If the coefficient of x squared, the neighbor of x squared, okay, before you read x squared in that quadratic equation, for example, this one here. So the neighbor of x is actually a +1 here. There's a +1 somewhere here. So there's a +1. So if the neighbor of x, or the coefficient of x squared, is a positive value, then that function has a minimum. It has n-shaped, sorry, u-shaped, I beg your pardon, u-shaped. So it has a minimum value. Then if it is a negative, for example, -2x plus 3x minus 4 is equal to 0. -2x, but this x is squared, of course. If the coefficient is a negative, then that function has an n-shaped curve, meaning it is maximum. So the value of y is a maximum value. So that's how we can tell the nature of the turning point. However, calculus can still help us. Well, graphical method is there, and also using completing square can still help us to determine the nature of the turning point, or the minimum and maximum value of the function. Otherwise, now that you've seen that using all the 4 methods we still get the same response, let's try out this assignment or activity. So using the following or the above methods, any of them, you can use all of them to prove the validity of your responses, or you can use one to solve the following. We have them, they are there, and the responses are already there, so you must get them. There are about 5, 6, 7, 8, about 10 tasks to do. Sit down, pause the video, try them out, and score yourself, given that the responses are already there. I think that will be enough for us to capture the knowledge of solving quadratic equation. And this knowledge is required whether you are in senior 1, senior 2, senior 3, senior 4, senior 5, or senior 6. You need this knowledge, because we still examine this, or we still indicate this in our items. So if you want to make it, please practice. Otherwise, let's get into how to determine the maximum and minimum value. We already discussed this in this previous page, and then we just need to emphasize on this. Now basically we have 3 methods that we shall use to actually obtain the maximum or the minimum value of the function. And here we are actually maximizing profit. If the scenario requires you to maximize profit, if the scenario requires you to minimize the costs of production, the expenses, the losses. So what they mean is they want the minimum profit. So you have to read the minimum value of the function. And if they want the maximum profit, did I say minimum profit? I beg your pardon. You minimize costs, you minimize losses, then profit you maximize. So if they want the maximum value, then you have to find the value of y that is maximum, and that will be the maximum profit. So by graphical analysis, you plot the graph, read the value of y, and that will be the maximum profit. And when you're plotting the graph, please, y will represent the profit, and then x represents something else as per the scenario. And then on the other hand, we shall use also completing square, where you express it in a perfect square form, and then read the value of x, and also the value of a constant that will act as the maximum or minimum value. Remember, the function has either a maximum or a minimum, but not both. So the function can't be maximum at the same time it is minimum. What are you? Next, by expressing the quadratic equations at hand in the form of a into x plus p squared, that's a perfect square, plus q, where p and q are constants. Q is a maximum or minimum. That is on a condition that that part, a into x plus p squared, is equal to 0. And when you solve, taking a square root on both sides, divide by a, ultimately our x is negative p. So negative p, if p is a constant, negative 2 then will be the maximum or minimum depending on the question. And I told you, you look at the quadratic equation, you vividly tell whether it will have a maximum or minimum before even they ask you to do that. So we make use of the knowledge of completing square. Number 2, graphical method, and explain that one. Graphical method, either maximum or minimum. And then by use of calculus differentiation, A level, you know this. You differentiate the function equal to 0, of course, at maximum or at minimum. And then solve for x. Use that value of x. Why am I talking about x? I'm taking a situation where a quadratic equation in terms of x. So don't cram it as all the time x. X can be even something else. So we are used to x because in most cases our quadratic expressions are always in terms of x. So if it is in terms of y, you have to differentiate that and get the value of y, substitute in the function. So respect the variables. But now for the new A-level competency based, you should know that it is you to choose a variable. So by default, we shall find ourselves using the same x. So you choose an appropriate variable that is not actually ambiguous. Let's say 0. You can't take a 0 as a variable. Let the number of x be O. O is like a 0. You can't take O to act as a variable. So by default, you find yourself using the x, y, and z. And then people will start asking whether we are still solving for x. Please, we are using the solved value of x now. The x which is representing the variable in the item at hand. Then we are using it to make valid conclusions, valid recommendations to the real life problems. So let's try the first approach of expressing the quadratic equation at hand in the form of a perfect square, such that the q you are seeing, the q plus q, there's a q here, we express it in terms of a perfect square, where this one is a q. So q is either maximum or minimum depending on the question or depending on the quadratic equation you have at hand. So let's try this example. Find the minimum. Of course, let's see. Yeah, since the coefficient of x squared is a positive 3, of course, that's the minimum. Yeah, and then state the value of x for which it occurs. So what we shall do is very simple. We shall use the knowledge of completing the square. For that case, since we don't want our x squared to have a coefficient which is not a positive 1, then we have to pull out that 3, or factor out 3, and then on factoring it, we can see that x squared plus 2x plus 13 over 3 is the quadratic equation we have whereby it's like we have divided through by 3. So that's why knowledge of completing square is required here. Now, since on this quadratic equation, where are you? Since on this quadratic equation we have we do not have something like is equal maybe to 0. So if it was equal to 0, it means this whole part, a constant, is to be taken as a negative 13 over 3. Then on adding the square of the coefficient of x on both sides, it means that we shall add here 1 squared. So if we had an equal sign just after 13 over 3, so we would be having is equal to something like that. Now, since all of them are collected to one side, it means that this negative 13 over 3 is a positive on taking it back. So that's why it's becoming a positive. And then this square becomes a negative when I take it back. So that's why it will become minus 1 squared. And this square is where? It's coming from the half of the coefficient of x. So you look at the coefficient of x here, which is 2. So when I get a half of, my friends in senior 1, you know this, a half of means multiplication. So you can cross out. So you get to realize that a half of the coefficient of x is actually 1. So squaring it, still it is 1 squared. Now I don't encourage you to first get the squared value. Write it as squared, then you add on both sides, because I'm targeting a perfect square somewhere. And to those who are following me, you are now picking what a perfect square is. So that's why some students find it hard and be like, hey, but this is a minus. Where is the minus coming from? Please, that minus is as a result of actually having everything of that square added on one side. So it becomes a minus. So just like you can see that. So this is what I'm talking about. So on adding 1 squared, I will add it on this part like this. I will add a 1 squared. Then for this part, since it is brought back with it is positive, then we shall subtract, because when it is having an equal sign, the other side we just add. So on adding, we just have a plus 1 squared. So I have to bring it back, cross the equal sign, it becomes a negative. So that's why it's become minus 1 squared. So all throughout your manipulation, be careful with this. So I'm trying to get a perfect square here. So I can see that x squared and 1 squared is to act as a perfect square. So I can collect them squared. This one I can simplify. 13 over 3 minus 1, that is 10 over 3. My target to express it in the form of a into x plus p, everything squared plus q. So I'm getting to that level. So when I bring back my 3, I get it in the form of a into x plus p squared plus q. And where we say the q is either maximum or a minimum. Since the question is minimum, then q is a minimum value, which is 10. Hence the minimum value is 10, and it occurs at a point when, to get the minimum value, it means that the whole of this part is a 0. So this whole part of it is a 0. So when I equate this one to 0, it can help me to solve for x, because I will take the square root on both sides. Besides that, even when I take just the whole of this bracket here is equal to a 0. When I take the square root on both sides, then I get my x, of course, as equal to negative 1. So that value of x is when we have the whole of this part equal to 0, and then what we shall remain with will be a minimum value of that very function. And if you plot this on a graph, you will get a U-shaped curve that the value of y will instead be 10. So that value of y will be the minimum value of the function. And if you do use differentiation calculus, let me just try with you that. My students of calculus, you know what we are talking about. So if you look at this function, if I want to get the minimum value, I have to differentiate. So when I differentiate this function, I will get 6x plus 6, of course with respect to x, and at that minimum point I will equate it to 0. Then I solve for x. Of course my x will be ultimately, when 6 goes the other side, becomes a negative, my 6 will be negative 6 over positive 6, and I will get a negative 1. So you get to realize that this is a point when the curve has a minimum value. So for us to read that value, get back this value of x and substitute in x, substitute in this x, substitute in this x. So this will be 3 plus, this is a minus 6 plus minus 6, which is minus 6, and then plus 13, and by the end of the week or by the end of the year we shall have 10 as the minimum value. So calculus, I've sorted you out. We can still use calculus by differentiation to get the value of x for which the function has a minimum value. And just in case it's a maximum, we still use the same. The principle remains: at minimum or at maximum, divide x. The derivative is equal to 0. We solve for x, get that value of x, substitute in the original function, read the maximum profit, read the minimum loss. Note, number 1, the quadratic equation has either maximum or minimum value, but not both. We use the same approach for maximum value. Even if you want a maximum value, use the same thing, depending on the question. And if the coefficient of x squared is positive, then the function, of course, I repeat that. So basically, that's what we can use. And then I will task you to do this activity. Find the minimum value of f of x, and the function is given. So why do you say minimum? Because the coefficient of x squared is a positive. And then find the least value. Least means minimum. Now, this is a fractional function, quadratic equation, but in a fraction form. So instead, what we shall do here is, you can see this one is a negative coefficient, so meaning it has a maximum value. So for me to get a minimum value here, for example, you have a function f of x. Kindly be careful with this. Those who are doing Ara formula, you know what I mean by maximum and minimum. So for me to get, let's call this as g of x, fractional function. Now for me to get a minimum of this, or the least value, then this is mean. Then this must be maximum. You must get 1 divided by maximum value for you to get the least value. Then if you want to get this as maximum, if you want to get this one as maximum, then the denominator here must be minimum. So of course we can surely see that a negative means that this quadratic equation has a maximum value. So I will need the maximum value of this part, then I take the reciprocal, I mean 1 over that maximum value. So that will give me a minimum value, and we'll try it out. So please be careful. You look at the quadratic equation in the denominator. If it has a negative, then that one you look for its maximum value, and then you take the division, 1 divided by that. If it is 2, 2 divided by that, 3 divided by that, then that will give you the least value of the f of x required. The same thing with Ara formula. Be careful with the denominator. They want a maximum value, then the denominator you must use the condition for minimum. If they want a minimum value, then the denominator you must use the condition for maximum. So kindly try this assignment, try this activity, pause the video, I repeat, pause the video. You don't do the work, you don't thank me later, I'm telling you. So number 3, find the greatest or maximum value of h. You see, they want the maximum, meaning down you have to take its minimum. But I'm guiding you on assignment. What am I doing? Find the greatest, still the same story. So basically, pause the video. You can also set your own question. After all, it is competency based, learner based. So verifying the nature of roots of quadratic equation using the discriminant. So what is the discriminant? From the general formula, we can see that the part b squared minus 4ac is the discriminant. So that's the discriminant. It helps us to verify the nature of the roots. And this nature can be either two distinct real roots, repeated roots, or complex roots. In bracket, no real root. So how can we do that? Case 1. When the discriminant is greater than 0. For that, the quadratic equation has two distinct real roots. And we shall verify this example. So I will ask you a question. What kind of turning point do you think this curve has? If you look at the coefficient of x. Respond in your heart. Next, response, the nature. We compare with the standard equation. We have a is 4, b is -9, and c is 1. We use the discriminant equation, b squared minus 4ac, substitute, and I can see as having 65, which is greater than 0. Therefore, it has two distinct real roots. So the activity is down. Please generate a quadratic equation with the two distinct real roots and prove it. Now, how do you prove? You use the discriminant condition, and also you can use any of the above equation methods to solve, and you get the two distinct real roots. We are still verifying case 2. So when the discriminant is equal to 0, of course, that is repeated root. These are situations where you solve the quadratic equation. To those who know how to use a calculator, you press the equal sign after substituting all the respective variables of a, b, and c. Instead, the calc gives you the same answer. x1 is 2, x2 is 2, or -1. So that is a repeated value, a repeated answer, a repeated response, repeated real root. So let's verify this. I still ask you a question. Which nature of the turning point, or which nature of the turning point does this quadratic curve has? Is it maxima or minima? Well, let's respond to this. How to tell the nature? A is 1, b is 4, and c is 4. Using the discriminant equation, b squared is equal to b squared minus 4ac, substitute everything, we actually get 0. Yes, that is a 0, because 4 squared is 16, then 4 times 1 times this is 16. 16 minus 6 is 0. Hence the quadratic equation has repeated real roots. You can solve this, you'll get the repeated real root. So still you'll generate 1, prove it using the discriminant condition, and also you can use a calculator. You can use bulldozer, the quadratic formula, to solve it. The last case is when the discriminant is less than 0, or it's a negative value. Then the quadratic equation has complex real roots. Is it complex real roots? No, it has complex roots, not complex real root. It has complex roots. Or it has no real roots. And these are situations when you're using the quadratic equation. As you're solving, you find the root of the equation not existing. As in that part of the discriminant, you take the square root of a negative value, and on pressing on the calc, you get a math error. So in most cases, you don't actually get a real root, instead a complex root. And to those who are familiar with complex numbers, we can still get those answers as roots, so complex roots. And then to my friends in O level, we stop there, because you can't get a complex root at that level. However, it's not even required. And then example, Verify the nature of the roots of the quadratic equation here. We still use the same approach, discriminant, substitute in the discriminant. You get a negative 7. Ideally, negative 7 is less than 7. Sorry, less than 0. And then this ultimately shows that the quadratic equation has no real roots or has complex roots. The activity is done. Generate one, please. Pause the video and generate. And please post your response. Post your response and we check. I just want to see how far we've moved. Note, one can use general formulae to prove or find the root of quadratic equation in the above cases. Yes, you can use general formula. You can use any method and you will prove it. Item number 1, now the scenarios, the real life application. A young astronomer who is Maya is working on a new telescope designed to find the planets orbiting distant stars. She discovered some interesting patterns in the web of a star, suggesting the presence of planets. However, her calculations are tricky and she needs to solve some quadratic equations. Maya's math teacher, Mr. Pero, left a cryptic note, and the note is here. The key to finding those hidden planets lie in mastering the quadratic equation. To find the planets, you need to solve these calculations. And the note has some examples of equations, but the solution method is missing. Luckily, Maya remembers some clue about the general formula from her past O-level mathematics classes. However, she can't state it correctly, and she needs your help as a student of principal mathematics. Task: help Maya to generate the formula. Maya calculates a web pattern for a star. She uses her measurement tools to get an example. She uses her measurement tool to get an example equation like this. 2x squared plus 5x minus 3 is equal to 0. She solves and gets 0.5 and negative 3 as possible values. Confirm whether her results are correct. So we shall not waste time, we shall still hijack. Of course, using completing square, we shall be in position to get the bull or the quadratic formula. The rule is very simple. Make sure the coefficient of x squared is 1. Identify the coefficient of x, but don't forget to take the constant cross equal sign. Get a half of the coefficient of x squared, the result add on both sides. Get a perfect square on the left hand side. Right hand side, simplify the expression, and we shall have b squared minus 4ac over 4a squared, because 4a squared is the LCM, the lowest common multiple. Take the square root of both sides. Take the square root of both sides, please. Don't forget to take a square root on both sides. Take the square root on both sides to eliminate that squared. And guess what? By the end of the week, we shall have the general formula Maya needs as x is equal to minus b plus or minus, because the square root of a number is either positive or negative. And we only take square root of those values whose square roots are whole numbers or whole values. So to part B, we just need to solve the quadratic equation Maya has to confirm the validity of her response using the general formula I have generated or we have created. Then we compare it with the standard A, B, C, 2, 5 and negative 3 respectively. We substitute, we get our answers as 0.5 and negative 3. Therefore, 0.5 and negative 3 are the possible solutions to Maya's quadratic equation that she will use to calculate the Weber pattern for a star.
abalala bendaba nange kwekute onkolele wakoleda abalala bendaba nange kwekute